Good morning, this is 6-1 GCF Factoring. We are going to be finding factors, numerical and variable expressions. You'll be doing page 264, 1 through 51 odd. Alright, so let's start with a factor is a whole number or a variable expression that divides evenly into a given whole number or variable expression. So, for instance, the factors of 18, if I were to make like a factor tower, this is like a little bit of a review from pre-algebra, the factor tower, I always go in order. I start with 1. Does 1 times what is 18? 1 and 18 divide evenly, so 1 and 18. 2 divides evenly, 2 and 9. I keep it in order. 3 goes in, 3 and 6. Let's see, 4 doesn't go, 5 doesn't go, and 6 is already up there, so I can stop. Okay, those are the factors. I don't need to do 9 and 2 because they're already up there. This is what we call a factor tower. So try it with 24. Now let's check. Try and keep it in order. 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5, no, 6, oh, it's already up there. Okay, so now let's try a variable expression. There's a number of ways that I could do this. 5 times, let's go 1 and 5xy. And that's really, I could do 5 times xy. It's just arranging it differently. I can do 5x times y. We can do 5y times x. So these are all the different factors that go evenly. I can break it up. How do we break it up? So when I ask you to find 3 factorizations for each monomial, now remember we can do 1 and 36, but don't forget we also have our negatives. So when it asks for 3 factorizations, this is the first 9 problems of the homework, you just pick any 3. Okay, 2 and 18, -1, -36, and, oh, they picked 2 and 18, and, just pick any 3. That's what you have to do, okay? Now, when you have variables, remember, you can break it up differently. So we can do -1 times this whole thing, 10x squared y, or I can do -2 times 5x squared y. And there's so many different ways to break this up. -5 times 2x squared y. I can do -10 times x squared y. I can do -1x times xy. So there's a number of different ways to break this. -2x times 5xy. Wouldn't that make 10x squared, right? -10x squared. I can do -5x, and so on. And I could do 5x. I could start my next round of -1xy times 1xy times 10x, right? So it really goes on. You just have to pick 3, okay? That you're not going to be able to, you're really not going to be able to check those answers in the back of the book because there's no way to come up with what you'd pick. Okay, a prime number has no other factors than 1 in itself, so like 7, 11. So let's go through our numbers. 0 is neither prime. 0 and 1 are neither prime or composite. Prime number starts with 2 because the only number that divides in is 1 in itself. Okay, so then we have 3 is prime, but 4 is composite. A composite number is anything that has more than 1 in itself as a factor. So the factors of 4 are 1, 2, and 4. 5 is prime, 6 is composite, 7 is prime, 8 is composite, 9 is composite. Remember 1, 3, and 9. 10 is composite, 11 is prime, 12 is composite, 13 prime, 14 composite, 15 composite, 16 composite, 17 prime, 18 composite, 19 prime, 20 composite, 21, 22, 23 is prime, 24 is composite, 25 is composite, 26 is composite. All these numbers are divisible by more than just 1 in itself. 28 is composite, 29 is prime. So I'm going to write these, and you may pause the recording and record them. We're just going up to 50. Okay, so pause the recording if you want to if you want to write those down, if you don't know what the prime numbers are, up to 50. All right. So another thing we learned in pre-algebra was prime factorization. So when we break down a number, we break it down to the prime numbers. So for instance, the first thing I do, I can take any two numbers that divide into 18, and I always usually put my low number on the left and my big number on the right. So I'm going to go like 2 and 9. 2 is a prime number, so I circle it. And I stop there. But 9 can be broken down further to 3 times 3. So 18, when I do prime factorization, basically I break it down to primes. When I multiply 2 times 3 times 3, these primes, I get 18. That's prime factorization. 2 times 3 times 3, or 2 times 3 squared. You go with 24. Go. Now let's check it. It doesn't matter if you do 2 and 2 and 12 or 6 and 4. You're going to end up getting the same thing. So they're going with 4 and 6. If you had tried 2 and 12, 4 breaks down to 2 and 2, 6 breaks down to 2 and 3. So the prime factorization here is 2 times 2 times 2 times 3, or 2 to the third times 3. Now, when you're breaking up a variable term, first thing you always have to do is split numbers and variables. When you break this up into prime factors, split numbers and variables. Okay, so we're going to break it down to 5 times xy. 5 can't be broken down anymore, but xy can to x times y. So your prime factorization basically is 5xy. Okay? These are all called factor trees. Where the other one was a tower, this is a factor tree. Okay, greatest common factor. This is our first form of factoring that we're going to be doing. It's the biggest common divider. The greatest common divider. You might want to write that down. The greatest common divider. Okay, greatest common factor is the biggest divider that divides into both these numbers. So we're going to break down 20 and we'll break down 20 to 2 and 10, or I don't know, let's see, they're going, 2 and 10. And then 10 breaks down to 2 and 5. And 24, let's see, they're going 2 and 12, and 12 breaks down to 2 and 6, and 6 breaks down to 2 and 3. So our greatest common divider we find by every time they have a match, we take it. That's a match, so we can multiply 2. I can take another pair of 2's times 2. They have nothing else matching, so 4 is the greatest common divider. Right? Okay, greatest common divider. All right, now this is you have to ask, okay, this is just a kind of a way of thinking. We're not going to really be doing it this way. I mean, you can, but we can do it mentally as well. So let's just first look at how we break down the numbers. Remember, when we have a variable term, you always separate number and variable. Okay, so 6 times m squared. 6 breaks down to 2 times 3. We're done. We can't break it down anymore. Those are prime numbers. M squared breaks down to m times m. Okay? 9m breaks down to 9 times mn. Right? Separate numbers and variables. Numbers to one side, variable, whatever, all the variables, even if there's multiples. 9 breaks down to 3 times 3. Mn breaks down to m times n. Now let's look for what they have in common, the greatest common divider. We can find a pair of 3's. So numerically it's a 3, and then we have a pair of m's. And that, my friends, is our greatest common divider, greatest common factor. I can pull a 3 and I can pull an m out of both. Okay, so now, I don't think we have to do a factor tree. Let's look at this. What's the biggest number that divides into both? The biggest number-wise numerical factor would be 3. What's the greatest amount of x's they both include? They both have at least one x in common, and they both have at least one y in common. So 3xy. Okay? Pause the recording and try 2 and 3 on your own. Okay, let's check our work. So let's see. I can go for third. I always go to the biggest number. And I kind of go to those factors. So 42 is 2 and 21, so they don't go. 3, no. 6, I believe it's 6. 6 goes into 30, 6 goes into 42. So 6, I can pull 2 A's out of both. They both include two A's. So a to the second, right? I can pull a 6 out of here. I can pull 2 A's out of both, right? And I'm left with another A here. And I can pull at least 1 B out of both. Whatever it is, it has to be matching. So 6 A to the second B is the greatest common factor. I didn't really cross them out, but I was just kind of... Okay, pause the recording, try the next one. Now let's check our work. 7 is the greatest numerical factor, and the greatest amount of m's we can take out that both include is m to the 4th, and the greatest amount of n's is n squared. All right, now let's look at another way. What is the missing factor? So x to the 10th is made up of x to the 4th times, now remember, when we have common bases, we really add the exponent. So what would I have to add here? It would have to be a 6. Okay? Exponents are added to make this exponent, but coefficients are multiplied. So on number 2, 2 times what equals 8? 2 times 4. And a to the 4th times a, what would I need to multiply by to get a to the 4th? I would have to get an a to the 3rd. So 4a to the 3rd is the missing factor. Pause the recording and try the next on your own. Okay, we're missing a 2. Let's try our answers. And we're missing an x, and we're missing a y, 2xy. Okay, for 4, 9 times what equals 36? It's 4. I need an a squared times a makes a to the 3rd. and then we need a b to the third to make b to the fourth. The next one I'm going to need a 7. And actually, how do I get that negative? How do I get 7 positive from a negative? So this is like a -1. So I'm actually going to need a -7, another negative to get it positive. And then we're going to need a x to the third and y, one more y to get us to this. This is our end result. Here I'm going to need a -2 and an h, and I'm missing a k squared. All right, so these are what we call missing factors. Okay, so here's, I'm sorry, the beginning of factoring. So step 1 in your factoring when we're factoring polynomials, there's all these different ways that we're going to learn. Today is greatest monomial factor, or GCF. It means GCF. And when we do this, it's just basically the reverse of distributing. So what could I divide out of 12 and 10? The biggest number. I can pull a 2. And then, okay. And so I'm going to you have to make a parenthesis. When I pull it out, here, when I divide it 2, and I can also divide an m to the third, but they both include the m to the third, right? So when I divide 12 by 2, I'm left with a 6. When I take out m to the third out of m to the fourth, I'm left with 1m. So when I multiply those back, it should equal 12m to the fourth, right? Sorry. When I divide 2 into 10, minus 10, I'm left with -5, right? And when I take an m to the third out, divide by m to the third, I'm just left with 1. So I don't need any more m's in there. So when I multiply this back, I should end up with what I started with. This is always a way to check when you're factoring. You can multiply it back, but please don't multiply it back because this is the answer of it factored. We divide out the greatest monomial factor, but we're still left with other things in the parenthesis. Okay, number 2. Numerically, 2 is the biggest number, and the greatest amount of a's I can take out is 1. So when I divide this by 2, I'm left with a 7. When I divide an a out, I'm left with a. When I divide this, oh, wait, I did that wrong. The greatest monomial factor is actually a 7, and I have an a. So when I divide this by 7, I'm left with a 2. When I divide a squared by a, I'm left with an a. Does that multiply to 14a squared? Yes. Okay, now look, when I divide -7a by -7a, I'm left with the number 1, not 0. Okay, try the next one on your own. All right, let's check our work. So numerically, 5 divides into all of them, and they all have at least 1x. So when I divide 15x to the third by 5x, 15 divided by 5 is a 3, and x to the third divided by x is x squared. Okay, when I divide 20x to the second, it's going to be a -4x, right? When I divide 30x by 5x, it's going to be +6. Now let's check our next one. The greatest common factor is a 4. We have the greatest amount of x's is x to the third, and the greatest amount of y's is y squared. So 4x to the third, y squared. So 4 divides into 8 twice. X to the third, I'm left with, I need one more x to make x to the fourth, and I don't need any more y's. Minus 4 goes into that 3 times. I don't need any more x's. There's no x's left. And there's 1 y. And then 4 goes into negative 20, negative 5 times. I have 1 more x, and I have y to the third makes y to the fifth. Okay? This is what we call greatest monomial factoring. Pause the recording and try the next few on your own. Now let's check our work. We can divide a 4a squared. That's it. They both don't. We only pull out what they have in common. Okay, this greatest monomial factor here. Now, if you had only pulled out a 2, every time you factor, you have to factor completely. If you'd only factored out a 2, I'm going to show you an example. So 4a, I'm left with a 3a here in the first term. And then in the second term, I'm left with 4b, minus 4b. Now let's say you had just pulled out a 2a squared. Okay, then you would be left with, let's see, I'll do it right here. 2a squared, 6a minus 8b. Now, the problem here is this is not fully factored. And if you give me this on a test, it would be marked wrong. To factor is to completely factor. And how do we know it's not completely factored? Well, look at this. These are both even numbers. That means there's still a 2 to be divided out. In addition, if I had not pulled all my variables out, also it would be considered not fully factored. So if I had just divided a, then I'd be left with I would be left with 6a squared and an a here. You would see there's a factor of a left in each of those. It's not fully factored. So when you factor, you have to fully factor. Pause the recording and try the next 3 on your own. Greatest amount of x's would be x squared, and the greatest amount of y's is y squared. Here we go. Okay, so I'm going to be left with x squared minus y to the third. Okay, next one, I'm going to pull out a 9, a squared b, and I'm left with 2a plus 3b minus, notice the sign is the same before, minus 4 minus 4b squared, b squared. If it were 4b, then these two would be like terms. Okay, greatest thing I can pull out is an x squared. When I pull x squared out of x to the fifth, I'm left with x to the third. When I pulled x squared out of x to the fourth, I'm left with x squared. When I pull x squared out I'm left with, now remember, when you divide any number by itself, x squared divided by x squared, anything divided by itself equals 1, so that would be plus 1. And you can always check, don't show it in your work because I don't want you to put that down as your answer, by distributing back. And if you get distribute back, it's basically the reverse of distributing. Factoring is the reverse of distributing. And that, my friends, is our lesson.